Yes, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. So we have covered your fuel pump now, right? So just a quick recap, okay? What we did regarding your fuel quality setting. So how we are carrying out fuel quality setting? How can we do it? What are the two methods? FQS. The last thing that we did yesterday. What is FQS?
So for that, we have to change the distance of pin and VIT arm.
Yeah. And the second one is individual racks up to 3 knob, isn't
Yes,
it?
sir.
VIT duct. And this in this system, you can see we have provided these two lock nuts to change the position of the pointer. But in some designs, also we have, you can see over here, this there will be a notch provided over here and a special spanner will be given. Okay. So you can adjust the compression of this part. Inside, I have a spring. Normally, there will be a spring. So spring tension can also be adjusted. Normally, most of the time nowadays, this system is there. This system is excluded. Okay. This nuts and type system is excluded. So what you're going to do, only going to adjust the spring tension by adjusting it from here. Okay. Is it clear? Yesterday I forgot to tell you about this. Okay. Is it understood? Inside I have a spring. I can adjust the spring tension by tightening this part, isn't it? Okay. So with that also you can adjust the FQS setting. Nowadays this system is being employed in which you can tighten the lower half of your position sensing. Okay.
So where is the spring?
Inside this I have a spring. Okay. So I am changing the spring tension accordingly. The compression of my pointer will be changed. Okay. It will change the compression, like how much pressure it is required to compress this pin also, right? So inside I have a spring. That spring compression I can change by adjusting this, cap. Okay. So there will be a groove given over here. If that system is there, there will be a groove given. You will be having a spanner. With that, you will tighten it more. If you tighten it more, it will be going inside and it will be tightening the spring tension, isn't it? Spring tension will increase. And with that also, you can change the FQS setting. Nowadays, this system is there. Okay. All right. So we'll go forward with your air compressor.
Sir, can you please make us write a statement that for the VIT, the operation of VIT, sir? If anybody asks that how it's operated, then in a statement, then please make us write, sir.
Uh, like you want to know about the operation.
Yes, sir. For the operation means what VIT is doing that that we know, but what is the operation of VIT? How it's operated? That in the words that if you can make us write, sir, then it's better for us.
All right.
सर एक चीज पूछनी थी। गुड मॉर्निंग सर। सर वो
Yeah, yeah.
जैसे आपने बोला वो स्प्रिंग मतलब जो सर्वो सिलेंडर है उसको मतलब उसमें है उसको स्क्रू को अनस्क्रू और स्क्रू कर सकते हैं तो उससे स्प्रिंग का जो पोजीशन सेंसर है वो डिफर करेगा। तो सर ऊपर अपना जो अपर फ्लकर और लोअर फ्लकर में अपर मतलब वीआईटी पे आई और नीचे जो अपना ब्रेक
Yes.
पॉइंट है। सर
Yes.
इन दोनों को मतलब इन तीनों में क्या डिफरेंस है? मैं बीओआई वीआईटी और ब्रेक पॉइंट तो समझ गया कि डिफर कर रहे हैं ताकि इंजेक्शन टाइमिंग और अपना चेंज कर सके सर, लेकिन वो स्प्रिंग जो पोजीशन सेंसर में जो वो लेगा स्क्रू उसको
Uh-huh.
चेंज करने से क्या फर्क पड़ता है सर?
Okay. Now, hold on. Let me open that diagram first of all.
हाँ जी सर।
I think this one, right?
Sir, does it control the air that is being sent to the servo cylinder
Yes, if position sensor, wait, let me
through the
just
spring?
put this thing over here, right? Then I'll explain it.
सर एयर का काम तो बस वही है ना कि वीआईटी रैक को एंगेज करना है ना सर।
Yes.
कितना
Okay.
एंगेज करना है वो भी वही कंट्रोल करता है।
Correct. The air
मतलब
pressure will
एयर।
dictate. The air pressure will dictate it. Okay. So I have
ओके
a
ओके।
cup over here. Okay. And it has threads. So I can screw it inside also. Inside I will be having a spring. Okay. There will be a valve over
ओके
here, which will be stopping your air supply, right? And this is the position sensor attached to it. This is the pin. Agreed?
यस सर।
So if I tighten it more, suppose I tighten it more, okay? The back cap, I tighten it more. So now this pin will require more force to get compressed and open
हाँ
the
जी सर।
channel for air to pass. Agree?
हाँ जी सर। हाँ जी।
Okay. So if I tighten it more, this spring will need more force. Okay. More force it will be needing so that this pin can get compressed, and that's why your what the pressure difference can create, okay, between
ओके।
your inlet and outlet. This is my inlet at 5.5 bar. This is the outlet.
हाँ
So
जी।
if I press it more, it will require more force from my VIT arm
हाँ
to
जी।
get compressed further and release more air pressure. Agreed?
जी।
This is this is only the fine adjustment when I have to do. This is only fine adjustment, okay? When I have to do the fuel quality setting, that means in ignition lag has increased. Suppose, okay, ignition lag has increase of the fuel, then sorry, then you need to inject fuel little bit earlier.
हाँ जी।
Agreed? What I will do, I will unscrew it, I will make it little bit back. उससे क्या होगा? The spring tension will be released and it will be requiring much lesser force to push this pin
यस।
inside.
यस सर।
Okay, when uh, it when it requires lesser force, then more earlier my air pressure will be building up.
यस सर।
Agreed? More pressure will be building up earlier, huh? पहले से ज्यादा रहेगा. Now my VIT racks will starts to move earlier, and if rack starts to move earlier, or VIT racks then moves in, your barrel comes down.
यस सर।
Okay, that will give me early injection, isn't it?
हाँ जी सर। हाँ जी।
Okay, that is how I'm telling you, by adjusting the back cap, you can adjust the spring tension, and with that, you can regulate. This is only fine adjustment, huh? Okay, this is only the fine adjustment that you can do. Okay, that if the ignition lag has increased, so certain degrees you can, shift your back cap in order to change the spring tension, and in order to, the beginning of injection up slightly, you can uh, do it early or delay, okay, by the
मतलब
spring
रिटार्ड कर
tension.
सकते
Okay, but this is only the fine adjustment. Main adjustment is only this one. This we don't touch normally. Okay, these fulcrum points we don't touch normally. These has to be done by your engine manufacturers. Okay, but this FQS setting can be adjusted by us. Is it okay? Because it will only finally adjust. Okay, it is a fine adjustment that we are allowed to do. Is it clear? By changing this cap or by screwing this cap, what is going to happen? Am
मतलब
I
सर
understood?
बेसिकली हम लोग इग्निशन लैग जो है वो रेक्टिफाई कर रहे हैं ताकि
Yes,
इग्निशन लैग ना
we
हो
are
और इंजेक्शन।
fuel quality setting is exactly for countering your ignition lag. Okay. If your ignition lag is more, what is ignition lag? This difference between the injection and the ignition of the fuel.
इग्निशन।
अगर वो ज्यादा
यस
है,
सर।
then I will give little bit earlier fuel injection so that I can cater that.
यस
Do
सर।
you agree?
तो मतलब सर एक चीज और, ये इग्निशन लैग से क्या आफ्टर बर्निंग भी हो सकता है क्या? अगर लैग आएगा तो फ्यूल
Yes,
बर्न नहीं
yes,
होगा तो?
it can lead to afterburning. Okay. So yesterday somebody has posted this thing.
सर एक वीडियो
That
डाला
only I
उसमें सर
remember.
उसमें। हाँ
You
सर।
can see
वो
it over here.
उसमें फलक्रम का पोजीशन भी चेंज कर रहे हैं सर।
Hold on. No, no, you're not changing the fulcrum position here. Okay. Fulcrum is set to its value, whatever has been set by your engine manufacturer. You can see over here, these, this part they have given a groove, right? The
यस
manual
सर।
that I showed you, it was a little bit older manual engine. In that, this system was not there. Okay. But in this, can you see the cap has a groove on which you can mount a tool and you can screw the cap in or outside.
यस
Okay,
सर.
and you can see the spring over here, and there's a valve which is preventing your airflow, isn't it?
यस सर.
Okay, and this is the position sensor, the sensor pin part. Okay, this is the VIT arm, this is regulating shaft. Okay, and this is the regulating lever. Now VIT lever. Now you can see over here the function, how it is functioning. Okay, and when I will screw my cap in or out, you can see, hold on. Now you see, if they will screw your back cap inside or outside, the spring tension is going to be changed. Not now. Hold on.
ये देखिए सर, चेंज हुआ ना सर, देखिए फलक्रम का
No, no,
पोजीशन
they
सर.
are changing and they are showing you what difference it will create. Okay, they are showing that.
अच्छा.
If you change it, what difference it will create. Now you see, now they are screwing and unscrewing. Now you can see what difference it will create. Can you see the difference now? Okay, with this, the force required from your VIT arm will be differ. Okay, and now it will be requiring more force to push it inside, and then pressure will release. Okay, this is only the for fine adjustment. Okay, that's why it is known as fuel quality setting. Okay, it is not the beginning of injection setting, not the breakpoint setting. It is FQS setting. Is it understood?
यस सर.
Yeah. Okay. This written part that you want, actually, you should write it off your own. Then only you guys can understand. But I will do it in the end of the class. ठीक है चलेगा?
ओके ओके सर.
वो लिखवाना है जो पूरा. But आप लोगों को you understood ना everything about it?
हाँ सर.
Yeah. Okay.
सर आज लास्ट में
सर
थोड़ा एमई और एमसी इंजन के डिफरेंस भी बता देना सर.
Fuel pump that will be taken separately. Huh? ME engine class will be taken separately. In that it will be covered your exhaust valves also, your fuel pumps also, and other mechanisms starting reversing also. Okay.
ओके सर, ओके सर.
Special class will be there for ME engines separately.
सर एक एक क्वेश्चन और लास्ट में बता दीजिएगा सर, अपना मेन इंजन का जो फायरिंग ऑर्डर होता है वो सीक्वेंस में क्यों नहीं रखते हैं?
Okay. Okay. I will cover it at the last. Okay.
हाँ सर, वही लास्ट में.
ठीक चलो ए
सर
कंप्रेसर पे
वो
आते
जो
हैं which is
वीआईटी
बोलो.
का जो मैकेनिज्म है उसके ऊपर मैंने लिखा है सर, तो मैं बोल सकता हूँ क्या? तो आप करेक्ट करोगे?
हाँ आप उसका फोटो भी भेज दो मैसेज पे एंड आई विल सी इट. ठीक है.
ठीक है सर.
Yeah. Chalo, air compressor. So air compressor, when we talk about, we have to see the method of compression. First of all,
दिस इज एमएसी नो सर?
what?
मेन एयर कंप्रेसर पढ़ा रहे हैं.
Yes, main air compressor. So one is adiabatic process. Second one is isothermal process. And the third one is polytropic process. Or you can say polytropic compression. Okay, here also you can write polytropic process or compression. Okay. So what do you understand by adiabatic compression? Anyone? Aaron, you have sent it for this thing?
यस सर, यस सर.
All right. Okay, well, at last we will see, ना पहले ये कर लेते हैं बढ़िया.
हाँ सर, हाँ सर.
Okay, adiabatic
सर
compression.
लास्ट में, सर सॉरी टू बॉदर सर,
हाँ हाँ बोलो
लास्ट में ना
बोलो.
एक बार ना वो जैसे वो एडजस्ट करने का नहीं आपने बताया था कि वो हाइड्रोलिक जैक लगा के हाइड्रोलिक पंप के थ्रू उसको फ्री कर देंगे, फिर एफके से घुमाएंगे, एक बार जरा फिर थोड़ा सा वो भी बता दीजिएगा लास्ट में प्लीज.
that cam part, fuel lead,
हाँ
cam lead.
हाँ 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 जी हाँ, कैमरूट से।
Okay, okay, okay.
हाँ, फ्यूल कैम लीड सर।
Yeah, yeah, sure, sure. Okay. Let us see the adiabatic compression. Anyone? What is adiabatic compression?
Sir, it's a thermodynamic process.
Mm-hmm.
There no heat is exchange between
Yes, no
system and
heat exchange will take place in adiabatic compression, right?
यस सर।
So, adiabatic compression of air is defined as the compression in which no heat is added or subtracted from air, and the internal energy of the air is increased, which is equal to external work done. That means if I take a cylinder, okay, suppose this is my liner of my air cylinder, okay, and there is a piston, okay. I do not want any heat exchange to take place. What I can do, I can insulate it. Suppose if I insulate this part, okay, I will insulate this part, and now this piston will, okay, insulation is there, and what I will do is I will make this piston go up. So if there is air inside it, okay, it will get compressed,
यस सर।
okay, and it will attain some energy.
यस सर।
Whatever temperature, whatever pressure it has increased, the volume has reduced, the temperature has increased, the pressure has increased, okay. So, but now this temperature cannot go outside, neither from the outside any temperature can come in. Agree?
यस सर। हाँ सर।
It is insulated. So
हाँ सर।
this type of process is known as adiabatic process, in which no heat exchange take place, and the amount of and the internal energy of the air, which right now it will be there, okay, is increased, which is equal to the external work done. External work done means something must have driven by this piston. Agree? A motor or
यस सर।
something. Okay. So what the motor has done work, okay, that will be equal to the energy that your air has produced after compression, if it is a insulated thing. Is it clear? What is adiabatic
यस
compression? Okay. Understood?
यस सर।
Okay. Now we'll go to second thing, that is isothermal. With the name, what does it mean?
सर, मीन वेयर द टेम्परेचर ऑफ द सिस्टम रिमेन्स कांस्टेंट थ्रू आउट।
Yes. Temperature of piston, temperature of the air. Okay. Even after compression, if the temperature is same, here in my adiabatic compression, will it be same? Suppose
नो
at
सर।
starting, the temperature was, for example, 30 degrees Celsius of the air. Will at the end of the compression, it will be still 30 degree?
नहीं सर,
Okay.
बढ़ेगा।
It will increase, isn't it?
यस सर।
But in isothermal compression, what we generally say, after the compression, if the temperature remains same, that is known as isothermal compression. Okay. So it is a isothermal compression is the thermodynamic process in which we decrease volume and increase pressure. Sorry, when the temperature of the system remains constant. Okay. So what does it mean? Suppose I have a liner and I have a piston. And now what I will do, suppose before compression it was 30 degrees or 35 degrees. After compression also it should be 35 degrees. For it, what I have to do? I
अंदर
have to cool
इंसुलेशन लगा
everything.
देंगे.
I have to cool it.
Yes, sir.
Agree? So that the heat exchange can take place. Okay. But both these process are hypothetical. It will never happen that complete isothermal process is not possible, isn't it?
Yes,
Even
sir.
complete adiabatic process is not also possible. Only in labs it is possible. In the labs you can do it. Okay. But practically when you think, it will not be possible to make a system isothermal completely or adiabatic completely. Agreed?
Yes, sir.
Yes, sir.
That's why the process that your air compressors follow, that process is known as
Polytropic.
polytropic, which is neither 100% adiabatic and which is neither 100%
Isothermal.
isothermal. Okay. So normally every compression starts adiabatically, then we try to convert it to isothermal. Okay. Adiabatic compression will try to convert it to isothermal, but because cooling करते हैं ना, right? In your air compressors, we are doing
हाँ,
cooling. So
हाँ,
we
sir.
are
Yes, sir.
trying
Water
we are
cooled.
trying to change the state from adiabatic compression to isothermal compression. But I told you 100% isothermal compression is not possible on board. Okay. It is only possible in your labs and all. So the process
Labs.
that it follows, it is polytropic compression, which lies between adiabatic and isothermal. Is it clear?
Yes, sir.
Yes, sir.
So the actual compression process of air compress compressor.
मतलब सर हम लोग टेम्परेचर घटा के प्रेशर बढ़ाएंगे नहीं सर, मतलब या कांस्टेंट रखेंगे.
We try to change a adiabatic process to an isothermal process, but isothermal 100% isothermal process, to achieve 100%, whenever a compression starts, it always starts at adiabatic. Okay.
ओके सर.
Any
ओके.
compression, whenever it starts, even in your main engine, even in your auxiliary engine, air is getting compressed na,
हाँ. यस.
compression होता है. So it
यस
starts
सर.
adiabatically. We try to change it to isothermal by giving it cooling, but 100% isothermal process is not possible. So the process it follows, it is known as polytropic compression, which is neither your adiabatic, neither your isothermal. Is it clear?
ओके. ओके. गुड.
The actual compression process of an air, which is in between isothermal and the adiabatic process. And it is referred as polytropic compression. Okay. That is for it, PV n equals to C, where n is approximately 1.25 to
1 पॉइंट.
okay. So do you understand what is adiabatic process, what is isothermal process, what is polytropic process? Is it understood?
Yes, sir.
Okay. Now if I have to draw a PV diagram of it, okay, normally काफी बार returns में बोलेंगे to draw PV diagram of it. So if this is P, this is volume, pressure versus volume, PV, pressure, volume. So if I draw it for suppose, this will be for adiabatic. If I have to draw it for isothermal, so this is for isothermal. If I have to draw it for polytropic, it will lie somewhere in between these two. Is it clear? What does area under the curve denotes?
The work done,
Work
sir.
done.
Work done. Okay, so you can see in your adiabatic process, this much area is there. Agreed? Work done.
Yes, sir.
And work done is proportional to your power required by your machinery,
Yes, sir.
power consumed by the machinery, right? So can I say I am also reducing the work done by trying to achieve an isothermal process? If I introduce intercoolers to cool down your stages or cool down the air, now if I try to achieve isothermal, will only this much will be my work done? Suppose I am able to achieve isothermal compression, will I can say I have reduced the work done?
Yes, sir.
And I can say power required by the motor will be also less. Power consumed by
Yes.
the motor will also be less.
Yes, sir.
Okay. All right. So this is your basic starting, what you have to understand, the compressions. Okay. Any compression, when it starts, it is starting as adiabatically. Then we are trying to change it to isothermal, but we cannot change it to 100% isothermal. Hence, it follows, whatever it follows, that process is known as polytropic compression, which is neither adiabatic, neither polytropic. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Now we'll discuss certain things which are really important, okay, as per your orals and writtens are concerned. So if I draw a cylinder, okay, I have a piston inside, for example. So I have a piston over here. So this is my TDC point of my piston. Okay, this is the BDC point of my piston. Okay. Now I will be having inlet valve and your return valves also, or delivery valve also. So this is my inlet. This is the outlet. In inlet valve, always I will be having filter.
Air filter.
Yeah. This is filter. Okay. Then in the piston, I will be having piston rings also.
Yes, sir.
All right. Now, a very important thing that we need to understand, that is known as volumetric efficiency. Okay. One of the most important questions that they can ask you, that is volumetric efficiency. What is volumetric efficiency and how will you define it? Okay. Yes. Tell me. Anyone has any idea? What do you understand by
Swept volume by total volume.
swept volume by total volume?
Total volume.
Okay, swept volume is, if suppose, what is my total volume here in this
From
figure?
TDC to BDC.
From TDC to BDC. So
Yes.
from, I can take it like this. Okay. What is this known as?
Total volume.
Total volume of this.
Stroke volume?
Stroke
Stroke volume,
volume,
right?
sir.
It's very stressful, bro.
Swept volume, stroke volume, right? Vs is equals to,
Right, sir.
okay. And next, what did you say?
Swept volume. The
Swept
actual
volume,
volume. Yeah.
actual volume. Actual volume is how much?
So वो थोड़ा सा कम होगा क्योंकि टीडीसी से ही हम लोग वो लेते हैं
Okay, okay, okay.
वन।
All right, all right. Wait. Now further I will tell you
From
few things. Further I will tell you few things. Okay. From TDC to extreme top of my liner, I have this much also uh, remaining part, isn't it? So
yes,
this
sir.
is known as
Clearance,
क्लियरेंस volume.
clearance
clearance
volume.
volume.
Okay. VC.
Yes, sir.
VC equals to clearance volume. The distance here to here is known as bumping clearance.
मतलब
PING
से
है.
लाइनर के टॉप से लेकर डिस्टेंस टीडीसी तक।
Yes. पूछते हैं ना ये सब बम्पिंग क्लियरेंस क्या होता है. ठीक है. From TDC point of my piston to the top of your cylinder head. Okay, whatever clearance is there, or you can say the clearance volume, कितना distance में है वो. Okay, that is known as a bumping clearance. Understood? And how much volume of air is stored in this bumping clearance? It is known as how much volume of air is stored in between this bumping clearance is known as clearance volume. Is it understood?
हाउ मच
How much volume of air is stored in the region of bumping clearance is known as clearance volume. This is clearance volume only, right?
Yes, sir.
Okay. So this is VC, this is VS. Okay. Now there is one more thing which is known as effective stroke.
सर सॉरी सर ये
Yeah, yeah.
अमाउंट ऑफ वॉल्यूम ऑफ एयर स्टोर्ड इन पंपिंग क्लियरेंस।
What clearance volume.
ओके ओके
Okay. Now there is one more thing which is known as effective stroke. Now what is this thing? Now suppose if I am going to compress air. So initially suppose my air was 1 bar. Agree?
यस सर
Atmospheric air came inside and it was suppose 1 bar. From BDC to again when it is going to TDC, it will get compressed. Agree? The air will get compressed in the clearance volume, isn't it? When BDC to TDC travel will be there of my piston.
यस सर
Okay. For example, the pressure now becomes at TDC approximately 6 bar. What will happen? The delivery valve will open and it will release the gas. Agree?
यस सर
But does my piston is still standing in my TDC? It will be moving, na?
फिर नीचे जाएगा सर।
Yeah. So suppose the air it is released sufficient air so that this pressure has reduced to suppose 2 bar. Okay. Now, for example, after delivery, the pressure which is remained inside my this clearance volume is 2 bar. Can this 1 bar pressure go inside now?
नहीं सर
It cannot go.
नो
Why?
सर
Because inside I have a more pressure.
यस सर
Let me just say 1.5. Okay. थोड़ा और realistic कर लेते हैं. Suppose it is 1.5 bar pressure, but still 1 bar pressure cannot enter inside, isn't it? Until this pressure drops below 1 bar. Agreed? Bolo.
यस
Do you
सर
agree? Okay. Now, when this 1.5 bar pressure will become 1 bar, when this piston will come little bit down here. Do you agree? Air will get, air will expand and the pressure will become now in this complete region become maybe 1 bar. Do you agree? Before it was, after delivery valve has opened and it became suppose 1.5 bar, but 1.5 bar, this fresh air cannot be introduced, isn't it? Can the fresh air can come inside?
No,
नहीं
sir.
सर
Okay. So this piston when go back to BDC, it will expand the air inside. then the pressure will drop down. When the pressure will drop down, then only my suction valve will open. Do you agree?
एक बार फिर से बोल दीजिए प्लीज.
Okay. So when I do the compression, okay, from the 1 bar region, suppose at BDC in my stroke volume, I was having 1 bar of pressure. Okay. Now after compression, suppose the pressure, this is after compression, my piston will go to TDC. Agree?
हाँ
Okay.
सर.
Suppose the pressure increased to 6 bar in this
हाँ जी.
cylinder. Okay.
हाँ जी.
Now my delivery valve will open and it will deliver the air. What will happen to this pressure? It will start dropping.
Yes sir.
Okay. So this pressure, suppose when the delivery valve closes, this becomes around 1.5 bar. Okay. And delivery valve
Yes sir.
closes. Now the pressure is 1.5 bar inside this chamber now. Okay. And my delivery valve has closed. So will there be any suction at this position? Will my suction valve
नहीं सर.
open? It
No sir.
cannot open. It will only open when this pressure has reduced below 1 bar.
Yes sir.
You agree? Okay. So the piston will move down. Okay. Piston will be moving down. And in turn, it will be expanding the air in that chamber. Okay.
And the pressure will reduce.
And pressure will reduce in this chamber. Okay. In this complete chamber, pressure will reduce to 1 bar. And that is when my suction valve can open.
Yes sir.
Okay. And piston is still going down. It will keep on sucking the air, fresh air, isn't it?
Yes sir.
So this point where actually the fresh air is being introduced. Now this is known as effective stroke, where actual fresh air has been introduced. Ideally, it should introduce at TDC, but actually when it is happening slightly late. And that's why the effective stroke thing comes. Do you understand? What is effective stroke? Bolo.
हाँ sir.
Okay.
Yes, sir.
So volumetric efficiency is effective stroke divided by stroke volume. Okay. Obviously, it is efficiency, so multiply by 100. Or you can say it, or volumetric efficiency is mass of fresh air. Fresh air will only be introduced at effective stroke. Agreed?
Yes, sir.
Yes, sir.
Induced in cylinder. Mass of fresh air introduced in the cylinder divided by mass of air in the stroke. Obviously, multiply by 100. I can write it as stroke volume is, or volumetric efficiency is, volumetric efficiency is, VE by VS multiply by 100. Effective stroke is VE. Stroke volume is VS.
Yes.
Okay. So VE by VS will give me
कुछ
volumetric efficiency. Do you understand what is volumetric efficiency?
Yes,
This
sir.
is one of the most important questions in your air compressor. Okay. Is it clear? Bolo, is it clear?
Yes, sir.
Okay. And this VC is approximately, clearance volume is approximately, it is about 5% of total volume. Okay, approximately. Sometimes they ask you how much approximate value of clearance volume is there. So that is 5% of total volume, approximately. Now, the questions that normally comes, okay, The cross questions that they will ask you when they will ask you what is volumetric efficiency. They will ask you how volumetric efficiency will reduce. Follow. See this figure? Tell me how my volumetric efficiency can
If
reduce.
if effective stroke is reduced,
Effective stroke is reduced. Excellent. How?
sir, if our
You're going
discharge
correct.
was
You're absolutely correct. But you have to define how it is getting. Can I go with the very basic things? What if effective stroke क्या है आपका? Mass of actual fresh air introduced. Agree?
Yes, sir.
Yeah. Now, suppose my filter is choke. Will that much amount of air will come in?
No, sir.
no, sir.
I can say this is one of the point. My volumetric efficiency will reduce. बोलो.
Yes,
If
sir.
suction ही नहीं हो पा रहा है, how the efficiency will come up, right? So if my filter is choke, that will also lead to volumetric efficiency drop, right? Second, what if these walls are leaking? My inlet and
So which
outlet
wall?
walls are leaking.
अच्छा, okay. Okay.
Yeah, it will also lead to that thing, isn't it? My efficiency
Yes,
will
sir.
again drop down. What if the piston rings? These are the piston rings.
Yes, sir.
What if these piston rings are leaking? Agree?
Yes,
Yes, sir.
sir.
What if my clearance volume increases? Or that means my bumping clearance increases, right?
Yes, sir.
These all will lead to VE to drop. If VE drops, then your volumetric efficiency also drops. Agreed?
Yes, sir.
Yes, sir.
So the first basic point you should the first point that you should say is your filter
Filter choke.
partially choked.
सर आपने बम्पिंग क्लियरेंस क्या बताया था? द क्लियरेंस बिटवीन द
Top
TDC
of
टू
your
टॉप ऑफ द
piston
लाइनर.
when it is at TDC to the top of your cylinder head. Okay. Or you can say the underneath of the cylinder head. Okay. That part. Then you can call it as piston rings are leaking. Then you should say walls leaking. Then clearance volume increases. Now he will ask you next question. Why clearance volume increases? Or how clearance volume can change? Just tell me how it can increase. How VC can increase.
Main
Think.
bearings worn out, sir.
Main bearing worn out. Excellent.
Problem in crankshaft, sir. Could be.
What problem?
Mm,
Crankshaft plug deflected.
Crankshaft deflected. आप कुछ extreme चले जाते हो एकदम. Basics से आओ ना.
So if the gaskets are squeezed or
Very good.
worn out,
Gasket is a very good option. Okay.
So
Squeezed
piston
वाला नहीं
head,
point है, but gasket is there. Okay. So
अगर
now
सर
you
क्लियरेंस
understand.
बिटवीन द
I have this liner. Okay.
सर अगर क्लियरेंस इंक्रीज हो गया तो
We are about to discuss how my clearance volume can increase. Okay. And I have a cylinder head. In between, what do I have? I have cylinder head gasket.
यस सर.
Now this gasket you are not making, huh? These gaskets are provided by your engine manufacturers or your air compressor manufacturers. Okay, you have to use the same gasket which is supplied to you. You should not make a GP gasket and you should not use it. Okay, because these are actually designed as per the thickness. Okay, their thickness is appropriate to create a proper clearance volume. Okay, if you use something else, it might thickness might not be correct, and if the thickness of cylinder head gasket is not correct, will the clearance volume can alter?
Yes, sir.
Yeah, that is one point. Second is, you can say,
While boxing up,
by using
if
the
we tighten
by
more.
not using manufacturers
Yes, sir.
supplied gasket. Okay, clearance volume can increase if you use a thicker gasket. Okay, suppose if you use a thinner gasket, then clearance volume will further reduce. Okay, okay. Now क्या करते हैं, what we do normally is we remove the gasket, but still little bit gasket sticks to the surface
हाँ
material.
सर, वो
Okay,
chip off करना पड़ता है.
if you do not buff it properly and on top of it you put a new gasket, maker supplied gasket it only use put, and then you put cylinder head, again your volume, clearance volume will increase.
Yes, sir.
Okay, gasket, old gasket not removed completely from uh, top of liner. Okay, then again you can lead to increase in clearance volume. Then if now these bolts are these cylinder head is tightened by the bolts, bolt and nut,
I
agree,
tried.
and these are tightened according to the torque,
I don't. Yes, sir.
right? So if the torque is not correct, it can also lead to, it will,
Change in
अगर आप over
pumping
tight
level.
करते हो तो gasket is going to get compressed further, right? Clearance volume can increase, decrease or increase, isn't it? With that also incorrect tightening torque. Okay, is it clear? Bearings worn out. Right? Do you understand?
Yes, sir.
Okay, just write it down. These points are very, very important. These two questions. Okay, they normally ask this. I'll just come in a minute.
सर लेड वॉल्व मेथड से सर ये वाली क्लियरेंस देखते हैं.
I'll come to that. Just wait for me.
क्या आयरन भाई, कितना पढ़ोगे? गुड आफ्टरनून.
गुड आफ्टरनून भाई. अरे वो लेक्चर अपलोड नहीं किया है था अपना इसका फुल कंप्लीट का.
क्या बोला सॉरी आपने?
कल का लेक्चर जो है ना फुल कंप्लीट का, वो अपलोड नहीं किया अभी तक. हाँ उसके तो.
अरे वो मैं भी शायद अभी करेंगे, बोलना पड़ता है भाई बार
हाँ
बार.
नहीं नहीं करेंगे, थोड़ा रुक जाते हैं.
हाँ, कर देंगे कर देंगे. अब मैं भी
हम्म,
शायद क्लास की बात करता हूँ.
हम्म.
भाई किसी ने वॉल्यूमेट्रिक एफिशिएंसी का स्टेटमेंट लिखा है अभी?
वॉल्यूमेट्रिक एफिशिएंसी का नहीं यार.
भाई किसी ने लिखा तो प्लीज ग्रुप में डाल दो यार.
कौन सा? तो सर ने स्टार्टिंग बोला था, होता क्या है डेफिनेशन?
नहीं उसका स्टेटमेंट चाहिए सिर्फ यार. वो तो बस फॉर्मूला लिखा हुआ है ना, इफेक्टिव स्ट्रोक बाय स्ट्रोक वॉल्यूम.
हाँ, इट इज द रेशियो ऑफ इफेक्टिव स्ट्रोक टू स्ट्रोक वॉल्यूम.
बस ये स्टेटमेंट है. इट इज द रेशियो.
हाँ हाँ हाँ.
हाँ
वही स्टेटमेंट भाई जो लिखवाया है, जो आपको फॉर्मूला दिया है, दैट इज द स्टेटमेंट. ओके, इट इज रेशियो ऑफ effective stroke divided by
effective
the
stroke.
stroke volume. Okay.
यस सर। सर उसके बाद
और
का एक
उसको
फॉर्मूला
और
दिया
ज्यादा
था ना,
आपको
मास।
और ज्यादा एक्सप्लेन करना पड़ेगा तो बोल देना that mass of actual fresh air introduced in the cylinder. Okay.
Mass of actual air introduced in
आपको लिखा है ना
cylinder.
ऊपर मैंने mass of fresh air introduced in the cylinder, actual fresh air introduced in the cylinder divided by the mass of air in the stroke.
yes, sir।
Okay, sir.
ये देखो ये लिखा है ना
हाँ हाँ।
क्या
हाँ हाँ सर।
सर थोड़ा स्क्रॉल अप कर दीजिए, वो लिखना है सर, हाउ वीसी कैन चेंज।
हाँ नीचे कर रहा हूँ तो
सर ये फिर अफेक्टिव स्ट्रोक का क्या रहेगा स्टेटमेंट?
व्हाट
अफेक्टिव स्ट्रोक का क्या स्टेटमेंट रहेगा? लाइक मास ऑफ एक्चुअल प्रेशर इंट्रोड्यूस, वो भी तो वो भी वही रहा ना?
हाँ the time when the mass of actual fresh air will be introduced from there to the BDC point will be your effective stroke length. Okay. The position of the piston when the actual fresh air starts to get introduced from there to the BDC point, that is your effective stroke. Let me know once you're done.
हो गया सर, लिख लिया।
Okay, so we'll
Done,
move
sir.
forward. Ah, done. Okay. Now, why do we? Next question that normally is asked a lot of times. Now you will see that you have multi-stage compressors, right? First stage, second stage, third stage, right?
Yes
ऐसा तो
sir.
है नहीं एक ही
यस सर।
पिस्टन है और वही आपको 30 बार दे रहा है, isn't it?
नहीं सर।
You have multi-stage.
यस सर।
Why?
To reduce the work
टू
done.
reduce the work done
To reduce the work done. How you are reducing the work done by
by
providing
decreasing the
multi-stage?
To
temperature, sir.
provide the high pressure air.
My question
So
is
by reducing
why
the temperature.
multi-stage? Wait. You said to what did you say?
To reduce
To
the work
reduce
done.
work done. To reduce work done. Absolutely correct. But how?
To reduce wear and tear of the
No,
component.
no. First explain this point.
Sir,
Reduce
by
work done.
by maintaining the temperature, by decreasing the temperature, and we're increasing the pressure, so volume is decrease.
Excellent. Okay.
So
Absolutely correct. So, first point that you should say to convert adiabatic process to isothermal process. What I do, first stage से compression किया, एक intercooler लगाया, okay, and it is going to the second stage. Agree? First stage, second stage. By providing the intercooler, I am cooling down the air. Suppose this inlet was first stage में 35 degree Celsius. For providing intercooler, I am trying to achieve second stage also to go at 35 degree Celsius. Do you agree?
it partially less than the temperature.
Obviously, it will not exactly 35. Okay. But it is, we are trying to do adiabatic process to isothermal process. Is it? That's what I explained to you. But it is not 100% isothermal also. That's why it
Yes,
is
sir.
known as polytropic, right?
Yes, sir.
So if I make a compressor in two stages, I can introduce a intercooler in between, which will try to convert the adiabatic process to isothermal process,
Yes, sir.
isn't it?
Yes sir।
Okay. Next is compressor becomes compact. I will explain you all these things. Then, sorry, work done is saved. then power reduced, power consumption reduces. Suppose this is the PV diagram of a single stage compressor. Okay, single stage compressor. This is PV diagram. This is the work done. Agree? This is PV diagram, na? Guys, you can hear me, right?
Yes, sir.
Yes, sir.
Suppose it is generating suppose 25 bar. Okay, for example. Now, if I introduce one more stage, suppose first stage is finishing over here. Okay, then what I am doing is at constant volume, I am reducing the at constant pressure, I am reducing the volume by, and then I'm again increasing the pressure in the second stage. So this is my second stage. This is the first stage. Can I say this much work done I have saved?
Yes, sir.
Okay.
एक बात
If I've saved the work done, can I say power requirement also is reduced?
Yes, sir.
Okay. Is it practically possible that I can produce 30 bar air from single stage?
Not possible.
not
Possible, but
possible.
it will take more
Possible,
time.
sir, but too much, the compressor size will increase.
Yes, the size is going to increase massively. Second thing, suppose if I generate 30 bar here, it reduces 27 bar. My effective stroke will be again more reduced,
Yes, sir.
right? This has to way more come down, then only my fresh air can be introduced. Agree? So efficiency drops, isn't it? अगर single stage सही,
बट
if I
सर
try
सर
to, yeah,
एक बार डायग्राम में फिर से ऊपर वाले में समझाएंगे आपने क्या सर पर वो तो जो एटमॉस्फेरिक एयर कूलिंग होती है ना सर उसके बाद वो कंप्रेस होगा फिर थोड़ा जाएगा फिर थोड़ा बचेगा
no, wait. Suppose I am generating 30 bar air in a single stage. Okay, I have a very big
मतलब
compressor, very big piston like your main engine. Okay, now these valves are not opened by any rocker arm or not opened by any oil pressure, right? These are naturally opened, isn't it?
Yes, sir.
यस सर
Okay, so suppose after releasing this 30 bar air, this air which is remained here after your delivery valve shuts, suppose it is 5 bar air remaining inside. Now this 5 bar has to become 1 bar, only then fresh air can introduce.
यस
Agree?
सर
Yes.
So suppose it will become somewhere here, then only this 5 bar will convert into 1 bar, and then only your fresh air can be introduced. So my VE will become very small.
स्मॉल यस सर
So what will happen to my volumetric efficiency?
It
इट
will
विल
reduce, sir.
reduce
It will reduce massively,
Yes, sir.
right? So if I use multi-stage, I can say my volumetric efficiency increases. Can I say it or not? अगर single stage
Yes,
में
sir.
volumetric efficiency is reducing, in multi-stage it will increase. Okay. Also, in each stage, I am reducing by intercooler. I am also draining the moisture content in my air. जो moisture है उसको मैं drain कर रहा हूँ. Okay, drain separators के through. So I am also increasing the quality of the air. Moisture is reduced. Quality of air increases.
सर कैसे सर थोड़ा एक्सप्लेन करिए मॉइस्चर
Yeah.
रिड्यूस
Wait.
इसमें तो अरेंजमेंट होता है ना अलग से सर वो मॉइस्चर के लिए
Yes. Okay. So what I do is Okay, so this is the simpler diagram of my tandem compressor, two-stage compressor. Okay, this is the so this is the fresh air being introduced inside it. Okay, through a filter. It is going here, going outside here, going to a cooler. After cooler, whenever it go air gets cooled, what will happen? Whatever moisture will be there, it will condense.
Yes, sir.
Okay, I can remove that moisture by help of my mist catcher, which is over
Yes,
here,
sir.
and I will remove that water. Agree? So can I say at this part, my quality of air will be improved? Also, the moisture will be reduced by introducing one more unit into it. Agreed? Then it will again go to second stage. Again, it will compress. Again, the moisture will be removed from the second stage. And then my air is going to my main air bottle. So can I say I am decreasing the moisture content and increasing the quality of the air?
हाँ जी सर, हाँ जी.
Agree? Everyone now?
हाँ जी.
Okay. Compressor, run cooler. Or compressor parts remain cooler. Okay. So if only one stage is generating my 30 bar, can you imagine how much temperature it is going to increase inside it?
हाँ जी.
Okay. So if I'm only generating in one stage, suppose 6 bar or 10 bar, and second stage my 30 bar. So accordingly, my compressor temperature will be reduced parts.
Yes, sir.
Yeah. And if I'm introducing this two stages, that's why I can make a compressor compact also. That means I don't
Yes,
need a
sir.
very big piston also. Agree?
Yes, sir.
My compressor will become, hold on. Little bit. Okay. So compressor becomes compact is understood. For a single stage, if I have to make single stage, I have to compress 30 bar. I need to have very big piston. I need to have very big liner, right? If
Yes,
I
sir.
do it in two stages or three stages, can I reduce the size of my engine, of
Yes,
my
sir.
compressor, right?
Yes. Yes, sir.
So these are the benefits of having a multi-stage compressor. Okay, this question can be asked in multiple ways to you. Why multi-stage compressor is required, or why we have two-stage compressors? Okay, why not a single stage? So can you explain it? What are the advantages? These are the advantages of
Yes,
having
sir.
a multi-stage, right?
Yes, sir.
You can ask you like this also. What is the advantage of having a multi-stage compressor? Same answer. Is it clear?
Yes, sir.
Okay. Sometimes a question will be asked. Explain reasons for drop in performance of compressor. चलो बोलो. Drop in performance.
Piston ring leaking.
Excellent. First of all, answer all the clearance, sorry, volumetric efficiency wale points. What all those points are?
Leaky piston rings.
Filter
सबसे
choke,
पहले
sir.
filter,
Filter
filter
choke.
choke. Next,
Valves leaking. Valves leaking.
Valves,
Inlet
piston
outlet
rings
valve.
and walls are leaking. Piston rings, walls leaking. Anything
Pumping
else?
clearance is more.
Clearance volume.
So clearance volume is
Clearance
more.
volume increases. Okay. Next,
Gasket not used.
insufficient cooling. In intercooler. दोनों स्टेज के बीच में इंटरकूलर है ना, फर्स्ट स्टेज सेकंड
यस
स्टेज.
सर,
Okay, so
इंटरकूलर
if
आफ्टर कूलिंग.
insufficient cooling is there, then also it will affect the performance, isn't it? Or
Bearing wear out. Bearing wear out.
wear ring.
Bearings.
Bearing,
Main
bearing.
bearings and bottom
Bearing
bearings.
that will come in clearance volume increase ना, वो सारे points पे आगे, right?
Okay, sir.
So air leakages. If your air leakages are more in the piping system and all, okay, so it will lead to again drop in performance.
Quality of air.
Okay, quality of air will come into the intercooler part only, right? Insufficient cooling में quality of air will not be that much good, right? So do you understand
सर
how
अनलोडर,
the
अनलोडर अगर
yes,
डैमेज अनलोडर अगर डैमेज है उससे भी कोई फर्क पड़ेगा?
yeah, that will also come into action, but you will come to know. Okay, if unloader is damaged, it will be
वो तो
not
रैटलिंग,
compressing only, right? You can say it. Okay, unloader not functioning properly or leaking unloader. All right.
The liner worn out, sir.
Liner worn out. That will come into this लीकेज वाले में आ जाएगा, बट ठीक है, वन आउट. ठीक है, do you understand? These are direct
यस सर.
questions, huh? These are some of the direct questions that they do ask you. Okay, what is volumetric efficiency? How clearance volume can increase or decrease? How your why multi-stage compressors? What what could be the reasons of your
सर
drop
ये
in
VC क्या लिखा है? VC increases means?
clearance
क्लियरेंस
volume?
वॉल्यूम.
Oh,
Yeah,
सर ये पीवी का जो डायग्राम बताया था थोड़ा सा एक बार बता दीजिए, मैं देख नहीं पाया था उसमें।
PV
प्रेशर
diagram
वॉल्यूम का डायग्राम।
for
अरे
a
ऊपर
two.
वाला सर.
Where did I draw it? This one. This is a
नहीं
single
सर,
stage. This
नहीं
is
नहीं सर,
single
इसके बाद
stage.
वाला सर, जहाँ
अभी
सर
आपने
वो
दिखाया था स्टेज,
This
मल्टी
one.
स्टेज
I,
दिखा
I, I
दिया
will draw it. I will
इसमें।
draw it. Wait, I will draw it a little bit better one. Okay. So this much is saved. Well done, saved. Even if I introduce third cylinder also, you can see how much work done will be saved, right? If I change it to 3 stages. Okay. So here where I am going to introduce intercooler. This is where I have introduced aftercooler. Is it clear?
यस
And
सर।
this much work done I have saved by introducing a 2 stage. This much work done is saved. That means I will be requiring much less power from my motor. Okay, that means much lesser consumption of my power, right?
sir, one query is there, sir. Sir,
Yeah.
they in the orals they are asking for function 4B. They are asking for only the main engines related components. No? For auxiliary engines, they are asking MEP, no, sir.
नहीं मैं समझा नहीं. For 4B what?
for function 4B, they are asking for main engine mostly. The questions are from main engine and generator.
Buddy, they don't think like this. Okay.
Yes, sir.
4B, they can ask you MP also.
Okay, sir.
I have seen that. Okay. In 4B, they asking MP question. In MP, they are asking motor questions. Okay. They
Oh,
normally
okay, sir.
doesn't think like that. Okay. Take it as one
Okay,
subject, both of these orals. Okay.
okay, sir.
But when suppose आपको 4B बचा हुआ है, concentrate more on main engine, but study little bit of your MP section also.
Okay,
Okay.
sir. Okay, sir.
Because they don't think like this. I have seen in when I was also giving orals, sometimes MEP wale section pe they will ask me questions regarding your stuffing box, your cross side. Okay, so you never know.
Okay, sir.
Okay,
सर
so
ठीक है सर
everything okay till now? Hello guys,
Yes,
सर
sir.
is everything
Yes,
okay
sir.
till now?
सर
Yes.
सर जैसे ये इंटरकूलर और आफ्टर कूलर में सर, जैसे जब एयर अपना अंदर आया उसको कंप्रेस किया तो प्रेशर टेम्परेचर वॉल्यूम सब बढ़ेगा ना सर?
अभी अभी उसी पे जा रहे हैं हम. ठीक है, डायग्राम ही एक्सप्लेन
ओके
करूंगा अभी, उसमें समझ आ जाएगा. Can
ओके
somebody
सर
please remove this line? Huh? Somebody has by mistake has made this line. Can you remove it? I cannot erase it. Otherwise, it will come in all these things. Okay. So by mistake बन गया होगा. If you can remove it, please, it will be very helpful. I think Anurag, it was you, maybe. Anurag is here.
नहीं सर मैंने सर
I
मैं
don't
ट्राई
know.
करता हूँ सर, मेरे से तो नहीं हुआ.
Okay, okay. All right. So this is a normal.
उस पे शायद पॉइंट करोगे ना तो शायद दिखता है.
दिखता है
नहीं, आशुतोष.
आशुतोष.
Yes.
आज
Actually नहीं दिखता यार.
आशुतोष
ऐसे I'm trying.
नहीं नहीं दिखता है, दिखता है सर दिखता है.
I cannot until he do. Like he is now doing, so the name is coming. Just tell him कैसे erase करते हैं. He will understand maybe.
आशुतोष भाई लेफ्ट में देखो, एक पेंसिल का कर्सर होगा, उसको क्लिक करके उस पर
हाँ
रबर होगा.
है.
उस उसमें उसको क्लिक
ओके.
करो. उसमें हाँ उसमें देखो एक रबर का कर्सर
Okay,
आएगा.
okay.
हो गया हो
हो
गया
गया
हो
हो
गया.
गया.
Thank you,
हाँ
thank you.
ओके.
Okay. चलो, let us discuss your diagram, line diagram. This is a tandem type of compressor. Okay. In tandem type of compressor, you have only one piston. Okay. And that one piston itself is doing two functions. That is first stage function also and second stage function also. So like this it will be. Okay. So the bigger piston will be for the first stage. The smaller piston will be for the second stage. Okay. One piston will be there, which will be having different proportions. You can see here one LP cylinder I have made, LP piston, and one HP piston. Okay. And this liner will also come like this only. Okay. Here. Sorry, not this one. Your walls, these two walls, what I've drawn over here, these will come here. Okay. Like this. A small change that you have to make in your diagrams. So I have a LP and a HP cylinder here. Piston, sorry, right? Piston rod is same for both and liner is same for both. Do you agree? This type of arrangement is known as tandem type compressors and these are normally water cooled. किसी ने काम किया इस पे?
हाँ जी सर,
Yeah.
मेरे में वाटर कूलर.
हाँ. So these are tandem type of compressors. Some are air cooled compressor in which LP unit will be separate, HP unit will be separate. ठीक है? So you will be having two pistons. LP piston will be different. Second stage piston will be different. Here I have only one piston, but the construction in such a way that it can work as both LP and HP. Okay. Is it understood?
मतलब सर पिस्टन रॉड सेम होगा, केवल पिस्टन का ऊपर मतलब
Yes.
एक पार्ट जो है सेम.
One long piston will be there, but the diameters of the piston will be varying. Here diameter is more, here diameter is less, right? But
ओके
it's a single piston. But in air cooled compressors, you will not see like this construction. You will be having separate piston for separate stages. Is it clear?
Okay, sir.
Okay, so this is my filter from which my atmospheric air will be going in. Okay, you can see I have written 1 bar 35 degrees Celsius. Okay, and it is going in from your suction valve. It is entering into this chamber. When it is getting compressed, it will be going out with 6 bar 110 degrees Celsius temperature. Okay, this is a pressure gauge mounted. This is LP relief valve. Okay, first stage relief valve. After that, it is going to the cooler, intercooler. Suppose it is a water cooled. Okay, so water cooling in, water cooling out. It is going inside the cooler. It will whatever moisture it will be condensed, that will be taken care by a mist catcher. Okay, mist catcher will remove the water content of the air, and a good quality of air will be supplied here. Now it will obviously become 6 bar and temperature will reduce to around 35. We are trying to maintain it to isothermal. Obviously, it will not be 35, 40 maybe. Okay, but here I have shown you 1 bar 35, यहाँ पे 6 bar 35. So I have converted into isothermal. Agree?
Yes,
Follow
sir.
guys?
Yes, sir.
Yeah. It will not be 35. Huh? It will be a little bit more than that, maybe 40. Okay. It will never go to 35. But just for explanation purpose, this diagram is for. Okay. Now it will go to your high pressure region. That is your second stage. Okay. Second stage में जाएगा. There it will further get compressed when the piston will come down. Agree?
Yes,
Actually,
sir.
ऐसे रहेगा cylinder. Okay. Cylinder will be like this, and these two walls will be coming over here, like this. Let an outlet. Okay. So I will just erase it for now. And this will be getting compressed further to 30 bar. You can see here 30 bar and 110 degrees Celsius, right?
Yes, sir.
Again, your high pressure relief valve, that is your second stage relief valve, your pressure gauge, it will go to after cooler. Okay. After cooler, after that, it is going to mist catcher again to remove any mist from there. Okay, any water content. And then it will go to your air bottle through a non-return valve to a air bottle. This is a filling valve of air bottle, and this is the main air bottle. So line is understood.
Yes, sir.
The same line will be there in your air cooled compressors also. Okay, the system that it follows, it's same. Okay, there only the difference is cooling media is air. A fan will be there in the front that will. Have you seen the fan in your air cooled compressors, guys who have worked in air cooled compressor?
Yes, sir.
Yes,
Yes,
sir.
sir.
हाँ
आगे एक
सर.
फैन रहता है, right?
हाँ, sir.
So it will look like something like this. Those who have not seen, ऐसा दिखेगा, isn't it? So these are the filters. I have two first
Yes, sir.
stages. First stage is here. This is also first stage. Two first stage, and this air will be going after this cooler. यहाँ पे cooler है. Okay, a fan will be there, and this is a cooler. Can you see the fins? These fins are given to cool the air. Okay, even on the cylinders they have given the cooler. This is your, what is this part?
Ready, sir.
Fan.
Yes, radiator. Okay, and inside you will be having a fan, right? So you can see here, that side was my first stage. This is the second stage. This is the third stage compressor. Can you see the difference in the sizes? Just see the size of this
Yes, yes, sir.
assembly, and you see the size of this piston. See the piston size of this one. Okay, it is becoming smaller and smaller.
Yes, sir.
Okay, this is decay compressor. This is emergency compressor. You can see the size difference also. First stage, second stage. Okay, difference is there. So why do I need to have a difference in size here? Here also I'm having difference in size. Size is different here. Size is different here. Second stage. Agree?
Yes, sir.
Why do I need this size difference?
Sir, we are doing that. We are decreasing the temperature at the small volume. We're compressing of more air. So
Yes.
to compress more pressure, so it's a less volume required, but
Very good.
temperature also decrease.
It is
So
depending upon the volume. Okay. You have compressed it here at 6 bar. Okay. If you give it on the same diameter of the liner, this air is going to get expand, isn't it? So you have to give a lesser diameter of piston, lesser diameter of liner. Then only you can compress it further. Agreed?
So
Suppose
one more time, one more time.
I have 3 units. One is this one. I have a bigger piston. This is air cooled type I'm explaining you now. Okay. And this is the outlet. This is the inlet filter. Outlet is going, suppose, 3 bar to the second stage. So it will go to the second stage through a cooler, obviously. Okay, intercooler, first stage intercooler, and then it will go to your second stage, which will be having much lesser diameter of your liner and your piston. If I put the same thing here, don't you think this 6 bar will again expand? If I have to further compress it, मेरे को size छोटा करना पड़ेगा ना?
Yes, sir.
मतलब वैक्यूम भी बन सकता है सर.
Yes, 10 bar. Again a cooler. And the third stage, then I will give a smaller piston and a smaller liner. Then only it will going to compress, right? Otherwise, वो expand कर जाएगा here. Agree?
Sir, if surveyor asking, then we can say to expand. There is a reason of expansion of the air, so we're decreasing the volume of the cylinder. So in high pressure,
If you want to increase the pressure, what do you have to decrease?
volume decrease करना पड़ता है sir.
Volume decrease करना पड़ेगा. ठीक है? You have to increase the pressure, you have to decrease the volume. Okay? Volume you can reduce by reducing the size of the piston and your liner. Clear?
Yes sir.
Yes sir.
You can see this is your PV diagram. As volume is getting reduced, my pressure is increasing.
Yes sir.
Yeah, same thing you have to do it here. Okay. All right. So diagram is understood first of all to everyone. What all parts are there inside it, that is understood to everyone, because one by one we will discuss all these parts.
Yes
Okay.
sir.
So
Yes,
you now know that every stage will have its own cooler. Every stage will have its own mist catcher. Okay. Mist catcher can be single also. Okay. It doesn't mean you might have two mist catchers. Normally it is a singular unit which will be having both the air coming to catch the mist. Okay. Then you know that unloaders will be there. Okay. Each unit should
Yes,
have
sir.
its own unloader. It could be compiled together also, sometimes in different type of unloaders. Then you both have your individual relief wall. That is very important. Individual relief wall will be there for both the units. Okay. First stage, second stage. If third stage is also there, third stage also will have its own relief wall. Okay. So parts is understood. What all parts are there inside your air compressor?
Yes sir.
Okay.
सर
चलो.
कभी कभी फर्स्ट स्टेज में ही दो सेक्शंस बने होते हैं ना, मतलब दो,
फर्स्ट स्टेज पे
जैसे सर ये आपने बोला ना फर्स्ट मल्टी स्टेज होते हैं, तो जैसे कभी कभी फर्स्ट स्टेज में ही तीन कंप्रेशन साइड होते हैं ना सर,
नहीं
मतलब
दिस
एक
इज
फर्स्ट
फर्स्ट
स्टेज में
स्टेज.
दो
सी
कंप्रेशन
सी
साइड.
सी वेट, दिस इज फर्स्ट स्टेज, this is second stage. Okay. The smaller piston is your second stage. This is first stage, second stage compressor. And in between
ओके
both
सर.
the compressor, I have introduced cooler. So I am trying to make it adiabatic to isothermal, right?
आइसोथर्मल. यस सर.
Agree?
यस सर.
Here in this diagram, I have 3 stage compressors. First stage, second stage, third stage. But for all three, I have different pistons. Here I have only one piston which is acting as first stage also, which is acting as second stage also.
सेकंड
Only the
स्टेज. यस सर.
design difference is there, and these are known as tandem type compressor. Okay, tandem type compressors. These are always water cooled type of compressors. Okay,
यस सर.
like this one. Those who have worked on tandem type, they will agree with it.
प्लेट टाइप कॉम्बिनेशन वाल्व रहता है ना सर, ऐसा कुछ तो बोलते हैं उसको.
Like this compressors you might have seen, right? ऐसे compressors थे.
यस सर, यस सर.
Yeah, these are tandem type compressors. You can see this is one unit, this is second unit. Okay, that means this unit will be having two stages. Okay, this is one more unit, like your main engine में हम separate units रहती हैं. Agree? For number one unit, number
Yes,
two
sir.
unit. Here also I have two unit compressors, but one unit will be having first stage and second stage separate. This unit will be having first stage and second stage different to give more amount of air to you. Is it clear?
Yes, sir.
Yeah.
तो मतलब टोटल 4 स्टेज हुए इसमें.
नहीं 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 बाबा, stage will be two only ना, first stage and second stage, and it is delivering air.
Unit, sir.
This is one more unit, okay, which is having first stage and second stage. So stage तो दो ही हैं, but we have increased the number of units, okay, to have
ओके.
more amount of air.
ओके सर.
Okay, quantity of air I am increasing. Okay,
तो दोनों में
like you can
दोनों में
you can call it as in they are connected in parallel.
ओके सर.
Okay,
That's like a reservoir, sir.
what?
That means like reservoir for occupying more air.
नहीं मैं समझा ही नहीं यार अभी भी.
सर वो मतलब दो स्टेज है फॉर ऑक्युपाई मोर अमाउंट ऑफ वॉल्यूम ऑफ एयर इनटू इट ना सर.
देखो यहाँ पे क्या है ना, इन दिस टाइप ऑफ कंप्रेसर यू हैव, ये आप समझ लो ये दो यूनिट्स है. वन यूनिट इज दिस वन एंड अनदर यूनिट विल बी हियर, सेम यूनिट, identical, and they together are supplying, okay, together they are supplying air to here. Is it clear? They are together supplying this air. Understood? I have two units. This is one unit, this is second unit. Both have first stage, second stage. Okay, like if I take an example of this one also, यहाँ पे भी I have two first stages. Can you see? This is also first stage. यहाँ पे भी first stage है. Have you seen this kind of
हाँ,
compressors? Yeah?
ये यही यही सर कह रहा था, ऐसा ही मेरा था सर, मेरे शिप में.
हाँ, so यहाँ पे आप यहाँ पे भी देखो, to increase the quantity of air, I have two first stage and one second stage, one third stage. Okay, here in the water cooled tandem type, to increase the amount of air, I am introducing two stages, two units. Okay, one unit with first and second stage, second unit with first and second stage. Both discharge will be together going to intercooler and all. Is it understood?
यस सर.
तो ये पैरेलल हो गया ना ऑपरेशन. Agree or not?
यस सर.
Okay, so stages will be two, but units are two. Okay,
बट सक्शन दोनों का अलग होगा, मतलब जो फर्स्ट यूनिट का जो ये एलपी का जो आउट रहेगा, डिलीवरी जो होगा वो सेकंड यूनिट में नहीं जाएगा, राइट?
नहीं जाएगा.
उसका
Both suction
इंडिविजुअल
will be
जाएगा.
different. Both
ओके.
sections will be different. Hold on.
बट जब वो लोग दोनों स्टेज के दोनों यूनिट के जो फाइनल स्टेज है, हाई प्रेशर स्टेज है, उनका जो डिलीवरी होगा वो कनेक्शन होके
कॉमन
फाइनल
रहेगा.
मेरे बोतल में
वो कॉमन
ओके.
रहेगा. डिलीवरी
वो
विल बी कॉमन.
कॉमन.
यू कैन सी यहाँ पे एक फर्स्ट ये स्टेज है, यहाँ पे एक स्टेज है. इसका फिल्टर सेपरेट है, इसका फिल्टर दे हैव ऑलरेडी रिमूव्ड राइट नाउ, बट यू कैन सी राइट, उसका आपको ये बॉटम फेस वाला दिख रहा है राइट. सो बोथ हैव इट सेपरेट फिल्टर. दोनों सेपरेट यूनिट्स हैं, बट दे आर डिस्चार्जिंग टू द सेम थिंग. ओके, लेट मी सी कहीं और से. यहाँ पे देखो, बोथ सिलेंडर हेड इज आल्सो डिफरेंट राइट. ओके, सक्शन इज डिफरेंट बट डिस्चार्ज इज कॉमन. ओके, चलो, we'll discuss air compressor further tomorrow. Okay.